Welcome, folks. We're going to do the second part of our notes here online so you can work at your own pace. If I go too fast, the nice thing about a video, you can pause and you can write everything down. So this is picking up in our notebooks. If you're doing the packets, you're going to pick up same place, fill in the spaces. So the last thing you should have written in your notes was ionic compounds, and I think we ended on polyatomics. So we've been spending a lot of time in class practicing how to write those polyatomic ions, how to write those ionic compounds, and now we're going to switch gears. So I had you watch a video on the difference between ionic and molecular compounds. Remember, the difference is that ionic compounds are made up of a metal plus a nonmetal. Molecular or covalent compounds are made up of just nonmetals. So those are the ones we're going to talk about today. To get started, molecular compounds, they can be called molecular or covalent. I don't care as long as you know what I'm talking about. And these compounds form between nonmetals. And in these compounds, they share their electrons. Ionic exchange their electrons, forming ions, while covalent compounds share their electrons. So they're also called molecules. So if you ever hear something called a molecule, it's because it's molecular. All right, covalent bonds. Again, we've already talked about this, but they're sharing their electrons, okay? And we learned it's a relatively complex naming system for the ionic compounds. For the formulas, we had to find charges, then use the crisscross method to write subscripts. You had to learn about polyatomic ions and those transition metals. And if you're still struggling with that stuff, please come and talk to me. You have to understand this. I don't want you to get mixed up with covalent compounds. Luckily, covalent compounds are a lot simpler than molecular compounds. Because they share their electrons, we just have to say exactly how many share them, okay? And how many of each atom is in a compound. So to do that, we use prefixes. We use these prefixes to name compounds, and we add the IDE ending on the end of them. So here's our prefixes. We just have 1 through 10. Those are the only ones you're going to need, okay? So 1 is mono, 2 is di, 3 is tri, okay? It's a good idea to memorize these, okay? You have to be able to know how to use these. You've got to know your prefixes, so memorize these. Write them down and memorize them. So let me show you how these prefixes get used. Okay, so when we're writing compounds, we use prefixes. And this note says, when writing the name of a molecular compound, if you only have one of the first atom, you do not need a prefix. Here's what I mean. We have CO2. Some of you might know this compound already, the name of it, just because it's a common compound. But let's look at it. C is for carbon, so we have 1 carbon and we have 2 oxygens. So when I name this guy, we have 1 carbon. Normally you'd think, oh, I need mono, that's the prefix. But it says if it's the first compound, we don't use a prefix if it's only 1. If it's 2, 3, or 4, 5, 6, we use a prefix. Only if there's only 1. So because there's 1 C and it's in the front, we name it carbon, and the second one dioxide. Okay, so we're adding that prefix and that IDE ending. If you're not sure how to write it, look at your pink sheet or ask. Okay, next one. 1 carbon, 1 oxygen. So carbon's in the front, so we don't need a prefix. But oxygen is the second one, so we need a prefix. So it's going to be carbon monoxide. That mono is our prefix. Right. Next one, nitrogen and oxygen. We have 2 nitrogen and 3 oxygen. So 2, the prefix is di, and oxygen, the prefix is tri for 3. So it'd be dinitrogen trioxide. Again, we add that IDE. Oh, sorry, clicked ahead too fast, but we have 1 nitrogen, 3 hydrogens, so it's nitrogen trihydride. Remember, if it's the first element and there's only 1, you don't need a prefix. That's the only time. Okay. So you're going to have a worksheet on this to practice this. You do need to know how to do it, but you have to make sure that you know the difference between an ionic and a covalent compound so that you can tell which naming system you need to use. All right. Couple more things we're going to talk about. Other molecules. Diatomic molecules are molecules that form between atoms of the same element. My example there is hydrogen. There's only a handful that do this. Di, the prefix di means 2. 2 atoms, basically, is what the name means. Here are the atoms that do this. 1 hydrogen, okay, So 1 is hydrogen. The other 6 are right here. There's 7 total. And the nice way you can remember that it's hydrogen, and then these guys over here actually make a 7 on a periodic table. So please get out your periodic table, highlight these, circle these, label them, whatever. You need to know these are diatomic. And all that means is when they are just by themselves, it's H2 or N2 or O2 or F2 or Cl2 or Br2 or I2. This is going to come up next chapter when we write chemical equations. Right, so make sure you have these written down somewhere so when I talk about diatomic molecules, you know what I'm talking about. We're going to pop ahead, and the last thing we're going to write down for today is about metallic compounds. So 1 was ionic compounds, 2 was molecular, and now 3 is metallic. Now metallic bonds are really unique. They obviously only happen in metals. It's when 2 metals are bonded together. Usually it's the same type of metal, but we have things called alloys when you have more than one type of metal. But it results in this attraction of these metal ions. And as you know, metals have very unique properties from everything else in the periodic table. They're shiny, they're ductile, they're malleable. It's why you can bend a wire and flatten it out into a sheet, but you can't do that with something like salt, an ionic compound, NaCl. If you tried to flatten a grain of salt, it turns into powder, right? You can't do that. And it's because of how they share their electrons. So, like I just said, this is why metals, they have electrons that move freely between atoms. This is what results in all those cool properties. And I have a picture here. If you take a look, these are metal atoms. So again, the nuclei of atoms are positive. So that's the positive nuclei. And these are those electrons. When they get close together, when they bond together, they just let their electrons flow freely. They can move around all those atoms within a metal. And that's why we can pound them out into a sheet, pull them into a wire. That's why they're really good conductors, because they don't need to hold on to their electrons like ionic or covalent compounds do. So they allow those electrons to move freely through them. Okay, so that's a metallic bond. That's as far as we're going to get into metallic bonds. They don't have any special naming system. It's just what metal is it. All right, that's where we're going to end today. I tried to keep it relatively short. We're going to pick up in class. Again, you're going to have an assignment. If you have questions, please let me know. All right, thanks, folks.